हेलो बच्चों, इस एपीसोड विच तुसी एक पॉइंट दा एक लाइन तो डिस्टेंस अते दो पैरेलल लाइन्स विचकार डिस्टेंस पता करन बारे जानोगे। आओ हुण शुरू करिए।
We can make use of the normal equation in order to find the distance of a point from the line. Let the distance of a point P with coordinates x1, y1 from the line L1, whose equation is ax plus by plus c equal to 0 is d. Now converting the equation into the normal form, we get a upon square root of a square plus b square into x plus b upon square root of a square plus b square into y equal to minus c upon square root of a square plus b square. It can be written as it is equal to p, where p is the distance of the origin from the line. Now through capital P, draw a line L2 parallel to L1. Distance of this line from the origin is OM. Therefore, D is equal to OM minus P. Let it be equation number 1. Because line L2 is parallel to line L1, therefore, normal equation of this line L2 is a upon square root of a square plus b square into x plus b upon square root of a square plus b square into y is equal to OM. Because point with coordinates x1, y1 lies on the line, therefore a upon square root of a square plus b square into x1 plus b upon square root of a square plus b square into y1 is equal to OM. Now from equation 1 we get D is equal to a upon square root of a square plus b square into x1 plus b upon square root of a square plus b square into y1 minus p, where p is equal to minus c upon square root of a square plus b square. Therefore, D is equal to a upon square root of a square plus b square into x1 plus b upon square root of a square plus b square into y1 plus c upon square root of a square plus b square. Or we can say that D is equal to ax1 plus by1 plus c all upon square root of a square plus b square. Since distance is always positive, therefore D is equal to modulus of ax1 plus by1 plus c upon square root of a square plus b square. Now we will learn how to find the distance between two parallel lines. Let two equations of two parallel lines P. For line L1, y is equal to mx plus c1. Let it be equation number 1. And for line L2, y is equal to mx plus c2. Let it be equation number 2. Line 1 will intersect x-axis at the point A, having coordinates minus c1 upon m and 0. Now distance between two lines is equal to the length of the perpendicular from point A to line 2. Therefore distance between lines line L1 and line L2 is D equal to modulus of minus m into minus c1 upon m plus minus c2 whole upon square root of 1 plus m square, or D is equal to modulus of c1 minus c2 upon square root of 1 plus m square. Now in general form equation of two parallel lines are ax plus by plus c1 equal to 0 and ax plus by plus c2 equal to 0, then d is equal to absolute value of capital C1 minus capital C2 upon square root of capital A square plus capital B square. Let us now look how to find the position of a point relative to a line. Let P be the given point having coordinates x1, y1 and AB be the given line with equation ax plus by plus c equal to 0. First, draw PM perpendicular to x-axis to meet AB in point Q. If PM is greater than QM, then it lies above the line. If PM is less than QM, then it lies below the line. Or let D is equal to PM minus QM. Therefore, if D is greater than 0, point lies above the line, and if D is less than 0, then point lies below the line. It should be noted here, two points lie on the same side or opposite sides of the given line ax plus by plus c equal to 0. When the coordinates of the given point are substituted successively for x and y in ax plus by plus c equal to 0, if we get same sign, the points lie on the same side, and if we get opposite sign, then they lie on the opposite side of the line. Angle bisector of line. The equation of the angle bisectors between the lines a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0. We know that the perpendiculars from any point on either angle bisector to the two lines are equal. Therefore, a1x plus b1y plus c1 upon square root of a1 square plus b1 square is equal to plus minus a2x plus b2y plus c2 upon square root of a2 square plus b2 square. These are the required pair of lines.
ਹੁਣ ਤੱਕ ਤੁਸੀਂ ਇੱਕ ਪੁਆਇੰਟ ਦਾ ਇੱਕ ਲਾਈਨ ਤੋਂ ਡਿਸਟੈਂਸ ਅਤੇ ਦੋ ਪੈਰਲਲ ਲਾਈਨਸ ਵਿਚਕਾਰ ਦੇ ਡਿਸਟੈਂਸ ਪਤਾ ਕਰਨ ਬਾਰੇ ਜਾਣਿਆ ਹੈ। ਆਓ ਹੁਣ ਇਸ ਤੇ ਆਧਾਰਿਤ ਕੁਝ ਉਦਾਹਰਨਾਂ ਨੂੰ ਹੱਲ ਕਰੀਏ।
Now let's see an example. Find the distance of the point with coordinates 1 and minus 3 from the line 4x minus 2y plus 21 equal to 0. Now its solution. The given line (4x minus 2y plus 21) is equal to 0. Let it be equation number 1. Now comparing equation number 1 with the journal equation ax plus by plus c equal to 0, we get a is equal to 4, b is equal to minus 2 and c is equal to 21. Let P with coordinates x1, y1 be the given point. So therefore x1 is equal to 1 and y1 is equal to minus 3.
that is given to us. So the distance of the given point P with coordinates 1 and -3 from the given line is D equal to modulus of ax1 plus by1 plus c upon square root of a square plus b square. So now placing the values of a, b, c and x1 and y1, we get D is equal to modulus of 4 into 1 minus 2 into minus 3 plus 21 upon square root of 4 square plus minus 2 square, that is equal to modulus of 4 plus 6 plus 21 upon square root of 16 plus 4, that is equal to modulus of 31 upon square root of 20, and that is equal to 31 upon square root of 20 units. So therefore the D is equal to 31 upon square root 20 units. जो कि ਅਸੀਂ पता करना ਸੀ। Now let's see another example. Find the distance of the point with coordinates -1 and 1 from the line with equation 12 into x plus 6 equal to 5 into y minus 2. Now its solution. Here the given line is 12 into x plus 6 equal to 5 into y minus 2, implies that 12x plus 72 is equal to 5y minus 10, implies that 12x plus 72 minus 5y plus 10 equal to 0 further implies 12x minus 5y plus 82 is equal to 0. Let it be question number 1. Let point P with coordinates x1, y1 be given point therefore x1 is equal to -1 and y1 is equal to 1, that is given to us. So now distance of the given point P with coordinates -1 and 1 from the given line is given by D equal to modulus of A x1 plus B y1 plus C upon square root of A square plus B square. Now comparing equation number 1 with this channel form AX plus BY plus C equal to 0, we get A is equal to 12, B is equal to -5 and C is equal to 82. Further placing these values in D with x1 as -1 and y1 as 1, which are the coordinates of the given point P, D is equal to modulus of 12 into -1 plus -5 into 1 plus 82 upon square root of 12 square minus 5 square is equal to modulus of -12 minus 5 plus 82 upon square root of 144 plus 25, that is further equal to modulus of -17 plus 82 upon square root of 169, that is equal to modulus 65 upon 13 units, because 169 is perfect square of 13, that is square root of 169 is equal to 13. Here we are taking the positive values of square root of 169, as distance can never be negative, so it is equal to 65 upon 13 units, that is equal to 5 units. So for the given example, D is equal to 5 units, जो कि ਅਸੀਂ पता करना है. Now let's see another example. Find the distance between parallel lines 15x plus 8y minus 34 equal to 0 and 15x plus 8y plus 31 equal to 0. Now its solution: given lines, (15x plus 8y minus 34 equal to 0), let it be equation number 1, and 15x plus 8y plus 31 is equal to 0, let it be equation number 2, are parallel as we know that distance between
parallel lines is given by D equal to modulus of C1 minus C2 divided by square root of A square plus B square. Now, from equation number 1 and equation number 2, A is equal to 15, B is equal to 8, C1 is equal to minus 34 and C2 is equal to 31. Now, placing these values, we get D is equal to modulus of minus 34 minus 31 upon square root of 15 square plus 8 square that is equal to modulus of minus 65 upon square root of 225 plus 64, and that is equal to 65 upon square root of 289 units, that is equal to 65 upon 17 units, because square root of 289 is equal to plus minus 17. Here, as distance can never be negative, therefore we will take the positive value of square root of 289, that is 17. So therefore, for the given example, distance between given parallel lines is 65 divided by 17 units, जो कि ਅਸੀਂ पता करना ਸੀ।
ਹੁਣ ਤੱਕ ਤੁਸੀਂ ਇੱਕ ਪੁਆਇੰਟ ਦਾ ਇੱਕ ਲਾਈਨ ਤੋਂ ਡਿਸਟੈਂਸ ਅਤੇ ਦੋ ਪੈਰਲਲ ਲਾਈਨਸ ਵਿਚਕਾਰ ਦੇ ਡਿਸਟੈਂਸ ਤੇ ਆਧਾਰਿਤ ਕੁਝ ਉਦਾਹਰਨਾਂ ਨੂੰ ਹੱਲ ਕੀਤਾ ਹੈ। ਆਓ ਹੁਣ ਇਸ ਤੇ ਆਧਾਰਿਤ ਕੁਝ ਹੋਰ ਉਦਾਹਰਨਾਂ ਨੂੰ ਹੱਲ ਕਰੀਏ।
Now let's see another example. Find the points on the x-axis whose distances from the line x upon 3 plus y upon 4 equal to 1 are 4 units. Now its solution. Let the point on x-axis be with coordinates x 0, given line x upon 3 plus y upon 4 is equal to 1 implies that 4x plus 3y upon 12 is equal to 1. Further implies 4x plus 3y is equal to 12. Further implies 4x plus 3y minus 12 is equal to 0. Let it be equation number 1. Now comparing equation number 1 with the general form ax plus by plus c equal to 0, we get a is equal to 4, b is equal to 3 and c is equal to minus 12. Therefore, distance of point whose coordinates are x and 0 from the given line will be d equal to modulus of ax1 plus by1 plus c upon square root of a square plus b square. Now placing the values of a, b and c, we get it is equal to modulus of 4 into x plus 3 into 0 plus minus 12 upon square root of 4 square plus 3 square, as x1, y1 are the coordinates of the given point, that is x1 is equal to x and y1 is equal to 0. So now further it is equal to modulus of 4x plus 0 minus 12 upon square root of 16 plus 9, that is equal to modulus of 4x minus 12 upon square root of 25, that is equal to modulus of 4x minus 12 upon 5, because square root of 25 is equal to 5. As distance can never be negative, we will take the positive value of square root of 25. Also, it is given that d is equal to 4 units. So this implies 4 is equal to modulus of 4x minus 12 upon 5, implies that plus minus 4 is equal to 4x minus 12 upon 5, implies that 4 is equal to 4x minus 12 upon 5, or minus 4 is equal to 4x minus 12 upon 5. Now when 4 is equal to 4x minus 12 upon 5, this implies 4 into 5 is equal to 4x minus 12, further implies 20 is equal to 4x minus 12, implies that 4x minus 12 is equal to 20, implies that 4x is equal to 20 plus 12, further implies 4x is equal to 32, implies that x is equal to 32 upon 4. On solving, it is equal to 8. Therefore, x is equal to 8, or when minus 4 is equal to 4x minus 12 upon 5, implies that minus 4 into 5 is equal to 4x minus 12, further implies minus 20 is equal to 4x minus 12, it can be written as 4x minus 12 is equal to minus 20, implies that 4x is equal to minus 20 plus 12, further implies 4x is equal to minus 8, implies that x is equal to minus 8 upon 4. On solving, it is equal to minus 2. Now, therefore, x can also be equal to minus 2. Therefore, for the given example, the points on x-axis are point with coordinates 8 and 0 and point with coordinates minus 2 and 0. जो कि ਅਸੀਂ पता करना ਸੀ। इस एपिसोड विच तुसी सिक्ख्या है the perpendicular distance d of a point P having coordinates x1, y1 from the line whose equation is ax plus by plus c equal to 0 is given by d equal to absolute value ax1 plus by1 plus c upon square root of a square plus b square. The distance d between two parallel lines y equal to mx plus c1 and y equal to mx plus c2 is given by d equal to absolute value c1 minus c2 upon square root of 1 plus m square. The distance d between two parallel lines ax plus by plus c1 equal to 0 and ax plus by plus c2 equal to 0 is given by d equal to absolute value c1 minus c2 upon square root of a square plus b square. If PM perpendicular to x-axis to meet AB in Q and D equal to PM minus QM, if D greater than 0, point lies above the line. If D less than 0, then point lies below the line. Angle bisector of line. The equation of the angle bisectors between the lines a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 equal to 0 is given by a1x plus b1y plus c1 upon square root of a1 square plus b1 square equal to plus minus a2x plus b2y plus c2 upon square root of a2 square plus b2 square.
इस एपीसोड विच तुसी एक पॉइंट दा एक लाइन तो डिस्टेंस अते दो पैरेलल लाइन्स विचकार डिस्टेंस पता करन बारे जानिया है। उम्मीद करदा हां तुहानू एपीसोड पूरी तरह समझ आ गया होवेगा। धन्यवाद।